Assalamualaikum to all the panels. Today I would like to present my final year project. Before that, I will to introduce myself. My name is Muhammad AMIRUL bin Muhammad ARIFFIN from 3 Bmmu, and my title for this project is to design, fabricate and analyze dark silencer using cone-house fiber for acoustical performance and by using appendage tubes. Next, okay, this is a presentation layout. As you can see, this will be the contents that I will be present today. Okay, next. Okay, first, introduction and problem statements. What is a dark silencer and what is the function of the dark silencer? Okay, a dark silencer is a noise control acoustical treatment of heating, ventilation, and air conditioning. Also, what we call as HVAC. And then it's also that have been designed to reduce the transmission of noise through the ductwork. Okay, and then we go to the problem statements. There are 3 problem statements. The first point is noise. Okay, noise is one of the most common occupational health issues in this industry that affecting workers' sleeps and physiological well-being. And this also stated by MOHD et al. For 2016. And then is a design of the dark silencer. Some comparison with experimental data show significant difference between theory and reality, emphasizing the limitation of the theoretical approach to the silencer, and it also stated by the Dibori et al. 2012. And the last problem statement is the type of natural fiber. Okay, the wrong choice of natural fiber will reduce the effectiveness of the dark silencer. Okay, and next we will go to the objective. Okay, first objective is to design and fabricate the dark silencer for the natural fiber bin test. And then the second objective is to analyze the acoustical performance of cone-house fiber for dark silencer. Okay, next, after the objective, we'll go to the scope. Okay, for the scope, first, design of the dark silencer with SolidWorks 2020 and fabricate the dark silencer using a selective laser sintering SLS 3D printer. Okay, first, the several design of the dark silencer being created and the best have been chosen, and it will provide benefit for this project. Among them is the dark silencer must be suitable for use on appendage tubes that used in this project. So the dimension of the dark silencer will follow the specific requirements that same as the appendage tubes. And not only that, but the type of shape also will need to be evaluated, and we'll choose which one is the best to run this project. And after that, second point, which is analyze sound ejection coefficient, transmission loss, and insertion loss of cone-house fiber. This is 3 parameters that will be controlled in this for this project. And then go to the effect. Okay, this is 3 effects that will be evaluated to run this project. First, effect of thickness and density of the cone-house fiber. Second, effect of design and the material use of the dark silencer. And lastly, the third one is effect of arrangement of a cone-house fiber. Okay, that's only the effect. And then we go to the literature review. Okay, the first literature review that the title is the application of coconut fiber as disruptive silencer, and this by Matlan et al. 2017. And from this project, it was arrangement of coconut fiber in the experiment. Okay, as you can see from the figure shows that experimental setup for that project. And then following the literature review, Sound Insertion Loss of Kinaf and Arenga Pinata by Madlan et al. 2020. From the experiment is conducted with difference of mass and the density of the natural fiber. Okay, from the figures shows that the insertion loss of Arenga Pinata and Kinaf as a parameter, and it states that those two natural fiber have been good to be sound adaptive material. And after that, we go to the next literature review, which is characterization of particulate matters and total VOC emission from a binder jetting 3D printer, and it by N. Ashraf et al. 2015. And it states that the advantage of using SLS machine as a 3D printing. So as you can see that the figure shows that the selective laser sintering SLS machine. And then the last literature review, the product data impedance tube kit type 4206, and it's by Brule and Kajer 2019. Okay, as you can see that it shows how the impedance tube work, and as you can see the figure shows the model of the impedance tube. And then we go to the flowchart. This is a flowchart of this project. And firstly, you start, and then next is introductions. From at the introduction, which is background study, problem statement, objective, and scope of the project have been stated at the introduction. And then go to the literature review. This chapter will include a summary of previous research relevant to this final year project, and also help with the project methodology. After that, go the design of the silencer, and also go to the fabricate the silencer will be carried out. And then after that, we go to prepare the contrast fiber and also insert the fiber into the dark silencer before be analyzed and be testings. Okay, after the analyze and testing, it will be carried out to the good acoustic performance. If have a good acoustic performance, it will go to result and discussions. If have no good acoustic performance, or have a troubleshooting, we will must go back to the design of silencer and need to be rechecked. Okay, that is the only for the flowchart. And then go to the methodology. Okay, as you can see, that is a block diagram for the experiment setup. I will explain about this. Okay, the figure shows the system layout of the silencer in this project. For this project, the 4 microphone transfer function method will be used in this project, and is also supported by experiment that has been performed previously by Brule and Kajer 2019. Okay, the extract contrast fiber will be placed inside the ducting silencer shell with different thickness and arrangement of fiber, with the ducting silencer combined with the impedance tubes. So the noise is generated from the loudspeaker. Okay, the noise will go to the microphone 1 and 2, and then go through the contrast fiber. At the contrast fiber, it will absorb the noise from the speaker, and the signals were captured by 3 and 4 that installed in 2 points on the tube wall. After that, the frequency signal will be recorded in the software. And then before experimenting, the calibration must be performed. Okay, for the first parameter that we need to analyze is a sound adjustment coefficient. Okay, microphone 3 and 4 are not used to measure this parameter, but in the second and third parameter, which is transmission loss and insertion loss, microphone 3 and 4 will be used to measure the data 1/3 octave frequency. And lastly, repeat this step with different thickness and arrangement of fiber, and all the data will be collected and being transferred to the computer software. Okay, that should also figure of the experimental setup. And then go to the morphological chart. This is a design that have been designed, and it have characteristics. Okay, first design is a triangle shapes, and the level difficulty of stacking fiber inside the shell is hard. And then shell size is bigger, and inlet and shell is combined and cannot be opened. And second design is a rectangular shape, and easy the level of difficulty, and also have a bigger shells, and the inlet dish and outlet shell are not combined, so it can be opened. And third design is cylinder, but level of difficulty for stacking fiber inside the shell is medium, and the shell size is small, and it also not combined that it can be opened. That is morphological chart. Okay, this is a preliminary result. Okay, for the final product design, as you can see in the figure, after proceeding with the designs and discuss equipment that has been used, one final design be selected as the design to be drawn in the SolidWorks 2020. The figure shows the final design rectangular ducting silencer chosen. Okay, this is named as rectangular ducting silencer, have been chosen for the duct silencer of conhas fiber. The other two designs, which are triangular ducting silencer and cylindrical ducting silencer, being rejected due to the presence of design is not suitable for this project. Okay, why choose this rectangular design silencer? Because it has more benefit than two other designs. First, the shell of ducting silencer has rectangular shape, and that's suitable for use for this research. And then the size of ducting silencer also ample, so it's suitable to put the conhas fiber into various configuration or arrangements. And next, the inlet and the outlet of the silencer can be opened, so it really helps and easier to treat the fiber into the shell of the ducting silencer. Okay, inside ducting silencer, we can see it have a splitter. Okay, what is use of this splitter? Okay, as you can see, the splitter is really help to arrange the fiber to test in these projects. Okay, it show this figure, which is have been arranged with 4 sides, 5 pieces, 4 pieces, and 3 pieces, and 2 pieces. This is the arrangement of the fiber will be placed. Okay, that's only for today, and thank you. I hope this project will get approval from all the panels, and I can continue this project to the PSM2, and also will help with the ducting silencer improvement for the future. Thank you, and Assalamualaikum.